Okay, so now we're going to be diving into your paper and talk a little bit about what's going to be expected of it. A lot of this information we'll be talking about is found in the communicating statistics section that I put up on the assignment page. You'll see that link. It's just a PDF of something that I sometimes talk about in class, sometimes I don't get to, but that's a resource for you. And it's essentially a guide for you to move through your paper and to make sure that you check all the boxes, you don't make common errors. And I'm just going to go briefly over some of those issues now. So the first thing you'll note is that this is essentially a checklist of the things you'll need. And we'll talk about each one of these. And you need the tricky part about this paper is that you need to hit all these things, but you only have 3 pages. So this is a maximum of 3 pages, not a minimum. If you can do it in 2, that's great. If you do it in 1, that's great. But it's a maximum. So if you go over, I penalize you. This is kind of really how writing is in practice, right? It has to be short. You have to get what you need to get across and do it as small of a space as possible. This is why I tell you things like make sure your tables don't take up any unnecessary room, because your tables are going to be in the memo and they're going to count to your 3 pages. Things that don't count to your 3 pages are like if you do go 1 or 2 lines over, but at the top of the page you had your name or something. Now, that doesn't count. That's fine. If you have some sources or something and you put those at the end, and now those sources make it go over to 4, make it go into 4. That's fine too. So I'm talking more about the actual content of the paper, from the title at the very top, all the way to the last word of the last line. So first thing you're going to need is an introduction, why people should care, and in that introduction you need a thesis statement. Now a thesis statement is not a question. It's not going to be what are the causes of crime or what are the causes of income. It is you're going to pick one of your variables and you're going to say this is the one, whatever one you're really interested in, and you're going to say this variable increases or decreases whatever your y variable is. And then you'll treat the other 2 x's, the other 2 things you put in, your other 2 independent variables as controls. Now, it is possible that in your statistical analysis, you did not find any statistical significance, and that's fine. If, however, you do not find any statistical significance, then you can't exactly say, well, race causes crime, when your evidence is race does not cause crime. One of the mistakes I see people make is that their evidence, their regression, does not match their thesis, which is obviously a problem. So you have to make sure they match. And if you don't find statistical significance, then you change your thesis and you say it doesn't matter. Now, to be clear, it's not sufficient to say this doesn't matter. You have to argue A, why by all intuition it should matter, and then B, why it doesn't actually matter despite that intuition. And that's what you'll cover in here in your story. Your story is your explanation, is your justification for a thesis statement. So your thesis statement, if there's no statistical significance, might be, people might think race matters because, there's all these like history of racism or like a tendency because of, some people tend to be low income, but it doesn't matter because of these other reasons. Race doesn't matter, here's my justification. Or race does matter, here's my justification. The story justifies your independent variables. Your story is essentially your proposal. Maybe a shorter version of that. It's saying, here are my justifications for why I'm including these variables. You need to justify all 3 of your variables, not just the ones that's in the thesis statement, but also your other 2, your controls. You have to justify why you're throwing in these other 2 variables into your regression analysis. Once you covered your story, you need a description of the data, so we need to be clear about what we're talking about. If we're looking at, say, alcohol consumption, is it in liters? Is it in gallons? Is it per year? Is it per month? Is it adjusted for population? Again, generally, everything should be adjusted for population. Some things don't make sense to adjust for population, like land area. But really everything, most things should be adjusted. So make sure that all that's clear. This is, by the way, where you put your summary statistics, so we know what you're talking about for all 4 of your variables. you're 3 independent, and you're 1 dependent. Then you actually run the regression, so you show the regression output. This is, again, the tables assignment, so you would put that there. This order, by the way, is not final, and just listing the things that, to me, this makes the most sense, but sometimes people flip things around, it still makes sense. It depends on how you do it. And then you discuss the regression in that, to the extent that it needs to be. And immediately you should do your punchline. This is kind of the most important part, right? It's literally 1 sentence long, but that 1 sentence is the entire point. It's not enough to say that, like, income causes crime. The interesting part, the real value added to the regression, is not merely that confirmation of that connection, but how much it matters. It's a question of how big is that coefficient. So that's just an interpretation that we've covered in class. For every additional, $100 or $1,000 that people earn, crime increases or decreases by this amount. It's useful sometimes to add a scalar. You see that I did that in the in the example. I think my coefficient, I was using time predicting exam total, and my coefficient was 0.7, which is kind of awkward because for every additional minute people get 0.7 points, but you usually don't get 0.7 points. You might get, usually the minimum change on an exam is 1. So I said, rather than saying for every minute student gets an additional 0.7 points, I just multiplied it by 10. I said for every 10 minutes, move that decimal place over, student gets an additional 7 points. And that just makes it a little easier. So, watch for those kind of things, like don't say for every additional dollar crime falls by 0.0000, and just say every additional 1,000 or something, so it makes sense, so it's a little easier to read and understand. It's not like anyone really makes a difference about $1 average increase in income. So make sure it's material, make sure it makes sense. But it's really just 1 line. But it's like the most important line in a lot of ways. Now, if you don't have statistical significance, then you obviously do not need this, right? Because your coefficient is 0, right? Essentially. You're saying this has no effect. That's a coefficient of 0. So while you do have to do a little bit more work here in the story, because you have to justify why it should matter by all intuition, and then also justify why it doesn't matter, why that intuition is wrong, there's a little bit less work here. Now, what we're doing is simple linear regression. This is very basic stuff. It is not perfect. If every single regression that people do, if you drill down, they have problems, they have structural problems, just because the nature of the data and all this stuff. And we don't go into any of those complications. But you should acknowledge the limitations of this analysis. So I do also require a paragraph explaining something that you're probably missing. Generally, this takes one of 2 forms. If you have statistical significance, you should identify a potential confounding variable. This is largely, from a writing standpoint, just to signal to any readers that you're not claiming things are this simple. You are acknowledging that things are more complicated. You might be missing something. It's a signal that you don't have full faith in this. You're not naive, essentially. It's a signal you're not naive. But it's also just good to sort of critically analyze your own analysis. And so that's what really this function is. Your node input. And so you just identify and justify a confounding variable. Of course, if it's a confounding variable, that means you have to justify why your variable would affect the y variable and why it affects the x variable that you chose, and do both of those in a way that makes the coefficient make sense. Like, I'm claiming x causes y, but it's possible that some third thing is causing both x and y, and it doesn't really matter as much as I say. If you do not have statistical significance, then confounding variable doesn't really make sense because there's no effect. But you could have omitted variable bias. So you should probably think about something that you're missing that if you controlled for, you would get an effect. Reminder, we saw that when we did the housing data. So when I did a regression analysis with just miles from the city center predicting housing prices. I got no effect whatsoever. And it's not because that location doesn't matter, it's because I had omitted variable bias. I didn't have size. So essentially you're looking for, following those same rules, a potential variable that's really important that you did not include. This is admittedly the hardest part of this paper. This stuff is really straightforward. This is the hardest part. And then you conclude, restate your thesis, summarize your argument. A couple of quick notes. Don't quote excessively, because that's typically just seen as kind of lazy when you quote a lot, right? You have very limited space, so use it very wisely. Review your work. Make sure you don't have any obvious errors. Don't use the word prove, because even if you find statistical evidence, you haven't proved a damn thing. Proof is for mathematics, right? You have the central limit theorem to worry about, right? P-values are never exactly zero. There's always a chance that what you found was connected by sheer coincidence. So don't say the word prove, right? You have evidence, but you haven't proved anything. Keep your causation straight. So sometimes people will essentially get it backwards when they do their analysis, and so they'll say like y actually causes x, or their story will be about y causes x when the regression is x causes y, stuff like that. So keep that in mind. Don't waste space explaining what you're doing. Like, don't say I ran a regression, because I can tell you ran a regression. You included a regression table. Oh, and that reminds me too, in the complications, make sure to include your correlation table, or somewhere include your correlation table, just to show that there is no multicollinearity. You might comment, maybe people usually do it right around here. You might comment, hey, there's no multicollinearity. Here's my correlation table. You're done. Right? You don't need to say I did a correlation coefficient on these 3 pairs of variables, and you can see there's no one. Like, I know you did the correlate. I can see the correlation table. Right, what are you doing? Right, you're wasting space. Don't do that. Because you have to include the correlation table. You have to show the evidence that there's no multicollinearity. I also want to remind you that there is multicollinearity. You have to change your analysis. You have to drop one of the variables, or maybe more if you have lots of instances of multicollinearity, and you have to swap it with something else. You always have to have 3 variables, at least. If you're using a dummy variable, like if you're using like region, for example, which is a series of dummy variables, that counts as 1 variable. Right? You can't say that my 3 variables are, is this in the west, is this state in the west, is this state in the south, is this state in the Midwest. It's like, well, that's really just 1 variable. That's just region. And finally, be confident. Don't be a wuss. Right? Don't say I think, I suspect, it seems, possibly, maybe, whatever. Don't be a wuss about this, right? Be confident. So if you find yourself saying, I think that, it seems that, whatever, it signals to the reader that you don't think you know what you're talking about, in which case the reader is going to ask themselves, well, why should I believe you? Right? Be confident. And I encourage people to be confident, because it also then encourages you to be correct. So when you say, no, this is how it works, that mentally encourages you to check to make sure that it actually works that way. Rather than saying, I think this is how it works, then you mentally say, well, I covered my butt. I said, I think. So I'm not going to bother checking to see if it actually works that way, right? Be confident. Be correct. Be compelling. Be concise. Good luck.